Hello once again, this is Dr. Daystorms, and we are continuing on in Chapter 1, and this is the fourth part, I do believe, which is the first time that you're going to have to just sit down and memorize a couple of lists of things. However, this is very, very important, and that's when we're going to start talking about the units of measurement. In science, we are going to be using what's called the SI units, that's System International Units, and there are 7 basic physical quantities that you need to know. You need to know that, the name of the unit, and the abbreviations for these. These are the most basic units that there are. All other units are components or functions of these 7 in some form or another. So, for example, we have mass, which the name of the base unit is the kilogram, not the gram. Many people mistake that. They make that mistake because they assume that it's just the gram, but it's actually the base unit is a kilogram, the abbreviation is kg. We have length, which is the meter, time, which is second, and I almost always use S. Very rarely do you see SEC used in my classroom. Temperature is the Kelvin. It's not degrees Celsius. It's actually the Kelvin, which is a capital K, and I'll explain that more later. Amount of substance, which is one that sometimes gives people fits. It's called a mole, which is abbreviated MOL. Electric current is the ampere, which is abbreviation A. And luminous intensity, which has to do with light, is a candela, which is abbreviated CD. There's one thing that you should notice that's missing. Many times I see people make the mistake and assume that volume is a basic unit, and it's not. Volume, believe it or not, is actually a function of length. So how is that possible, you may say? Let's find out. Just a second. Volume is most commonly used when we talk about the liter and the milliliter. So where does this term milli come from? Let's go back. Okay, we have to use prefixes to convert that base unit into an appropriate size. And I want you to memorize these prefixes. You're probably used to seeing milli. Milli is 1 times 10 to the minus 3. That means it takes 1,000 millimeters to make 1 meter. Or 1,000 milliliters to make 1 liter. Okay? Centi is 1 times 10 to the minus 2, so it's 100 centimeters for 1 meter. However, kilo is 1 times 10 to the power 3. So 1 kilometer is equal to 1,000 meters. Many times you hear about the term nanotechnology, which just refers to something being very, very small. But a nano is 1 times 10 to the minus 9. So it's going to take 10 to the power 9 nanometers to make 1 meter. Make sure you understand how these prefixes work. So let's go back to volume. You can imagine, because we use like the term liter and milliliter. If you imagine a cube that has its 1 meter on each side. Okay? And we take that and we divide it up into tenths. Then we take that and we divide it up again into tenths. So now we have 1/100th of that 1 meter cube. So now we have this little cube that's 1 centimeter by 1 centimeter by 1 centimeter. So if you take the volume, 1 times 1 times 1, it's going to be equal to 1 cubic centimeter. That 1 cubic centimeter is equal to 1 milliliter. Which, if any of you have been working around medical fields, a lot of times you'll hear about, for example, give so-and-so 10 cc's of something. That's 10 cubic centimeters, which is equal to 10 milliliters. So I do expect you to know the conversion factor of 1 cubic centimeter is equal to 1 milliliter. That's the extent that we'll go with respect to volume. Okay, temperature. I usually, whenever I've asked students before in the past, like, what is temperature? They'll say, oh, it's the measurement of heat, which isn't quite accurate. In reality, it's a measure of the average kinetic energy of the particles that's within that sample. The three scales that are often used, well, here in the States, of course, we use Fahrenheit. So the body, is 98.6 degrees Fahrenheit. Water boils at 212 degrees Fahrenheit, but that's not very useful. And so then came along the Celsius scale, and the Celsius scale is actually based off of water. Water then freezes at 0, and it boils at 100, and therefore our body temperature, the average body temperature, would be 37 degrees. That's quite useful. Many times we do use Celsius in science, and when we talk about writing down boiling points and things like that, usually in the chemistry lab, we will use Celsius. We will not be using Fahrenheit. However, it's not necessarily the most practical because you can either go to really high temperatures or really low temperatures. In fact, you can go to such a low temperature that the particles in an object would completely stop moving. That's called absolute zero. And so, absolute zero is 0 degrees Kelvin. Okay? And that's what we use as the SI unit of temperature. At 0 degrees Kelvin, the particles would stop moving. That's as low as you could ever go. The kinetic energy then approaches the limit of 0. And so, therefore, if you want to convert between Celsius and Kelvin, it's actually quite simple. Okay, it's to go from Celsius to Kelvin, you just add 273.15. And I just want to reiterate the fact that there are never negative numbers in Kelvin temperatures because you cannot go below 0 degrees Kelvin. 0K is when the movement of an atom will cease. Alright, so there's never a negative number. You do encounter negative numbers between Celsius and Fahrenheit. I would give you, on an exam quiz, I would give you these equations. I would just expect you to know how to use them in order to convert between Fahrenheit and Celsius. So, for example, if we say, oh, it's beautiful outside right now, it's 75 degrees Fahrenheit, what is that in Celsius? Okay, so let's convert between Fahrenheit and Celsius for 75 degrees. All right. Okay, so the equation that we'd be using is Fahrenheit is equal to 9/5, I'm just going to say Celsius, plus 32. So let's just go to algebra. Be F minus 32 is equal to 9/5 Celsius. Now we want to multiply by the reciprocal. So 5/9 times F minus 32 is equal to Celsius. So now we just plug and chug. 5/9 times 75 minus 32. So we utilize our calculator. Let me get this out. 75 minus 32. Times that by 5/9. And it's roughly 23.2 9 degrees Celsius. And please note, whenever you're using that in Kelvin, you don't use a degree sign. They just use K. All right. Density is a physical property of a substance, and it's a relative ratio of the mass per volume. So density is equal to mass times volume. So let's figure this out. So if we have a block of wood, it measures 10 centimeters by 2 centimeters by 5 centimeters, and it has a mass of 250 grams, what is its density? The first step here is we need to solve for the volume. Volume is length times width times height, so we're going to have 10 times 2 times 5. So the volume is going to be equal to 100 cubic centimeters. Now we just plug that into the density. D is equal to the mass, 250 grams. Divide that by 100 cubic centimeters. I'm going to get 2.5 grams per centimeters cubed. Units are important. I do deduct if you do not include your units. Okay? You don't want to lose the easy point, so to speak. Likewise, if I said to use it to solve it for units in grams per milliliter, which is commonly used for density, since 1 cubic centimeter is equal to 1 milliliter, this is the same thing as saying 2.5 grams per mil. Just don't forget your units. Hopefully this has helped you learn a little bit about the use of units and the SI units in particular. That concludes this lesson.